Hello students, today's point of discussion is third law of thermodynamics. Now according to the Nernst theorem, as temperature decreases, change in heat capacities at constant pressure and entropy approaches to zero. I mean at absolute zero, delta Cp and delta S approaches to zero. So remember, then what delta Cp is? Remember, delta Cp is the change in heat capacities, So that can be given as, so delta Cp equals to Cp of product minus Cp of reactant. So let's see what happens as temperature decreases. As temperature decreases, delta Cp goes on decreasing. I mean difference becomes lesser and lesser. And remember, at absolute zero temperature, that is at 0 Kelvin, delta Cp approaches zero. So what it means? It means that at absolute 0 Kelvin, Cp of product becomes equal to that of reactant. So this is very important thing, that is Cp of product becomes equal to the Cp of what? Reactant. As Cp of product and Cp of reactant becomes equal, definitely delta Cp comes what? Zero. So this can be easily given as what? Limit t tends to 0 of Cp is nothing but 0. I mean as temperature decreases, then heat capacity goes on decreasing, and at absolute 0 of temperature it becomes 0. Now as per the Nernst theorem, another important generalization regarding entropy change, this can also be announced as delta S, that is change in entropy, approaches 0 at 0 Kelvin, that is at absolute 0 of temperature. So let's see what it means exactly. Remember, delta S is nothing but the entropy of product minus entropy of what? Reactant. So when temperature decreases, then this difference goes on decreasing, and at absolute 0 of temperature, what happens? Entropy of product exactly becomes equal to that of reactant. So at 0 Kelvin, entropy of product is equal to entropy of reactant. So thus the difference between these two, I mean entropy of product minus entropy of reactant, is 0 at absolute 0 Kelvin. So this is very importantly given as limit t tends to 0, entropy equals to 0. I mean with decrease in temperature, entropy goes on decreasing. So this lead to the enunciation of the third law of thermodynamics. So what third law says? Remember, according to third law, entropy of any substance at absolute 0 of temperature, that is 0 Kelvin. Again I repeat, at 0 Kelvin, entropy of any substance may become equal to 0, but it does become equal to 0 in case of perfectly crystalline solid. So in one word, one can say that at absolute 0 temperature, entropy of perfect crystal is 0. This is nothing but the third law of thermodynamics. So what third law says? At 0 Kelvin, entropy of any substance may be 0, but it does become 0 in case of perfectly crystalline solid. So perfect solids have zero entropies at absolute zero temperature. So what it means, what it indicates, remember, at absolute zero, crystal means particles of crystals are perfectly and orderly arranged. Very first thing to be noted. So what happens at 0 Kelvin, particles of crystal are orderly arranged, very first thing, and that crystal is in the state of low energy content. I mean, at this state the crystal has low energy. So and crystal has lower energy, and remember, lesser the energy content, greater will be the stability of that crystal. So this is the third law of thermodynamics. Thank you very much.